In this lesson, we will learn how to calculate the volume of prisms and cylinders and use those volume formulas to solve design problems. Recall that the volume of a three-dimensional figure is the number of non-overlapping cubic units contained on the interior of the figure. So for example, in this figure, each one of these cubes is a unit cube. Therefore, the volume of this figure would be 1, 2, 3, 4, 5, 6, 7, 8 cubic units. Suppose we wanted to develop a formula to find the volume of a prism or a cylinder. Okay. So what we're going to start with is the base of this prism or cylinder. In this case, it would be a prism that we're going to build. Notice that, let's say that the area of this, the base of this prism is b square units. We continue constructing our prism by making a prism that has a height of 1 unit. Well, since the area of the base was b units, the volume of this prism would be b times this height of 1 unit. So the volume of this three-dimensional figure is b cubic units. Suppose now that we continue building our prism to its finish by saying that our prism has a height of h units, okay, which means that there are b times h units on the first floor, you could think of it as. And how many floors do I have? I have a total of h amount of floors. Okay, so the first floor contains b times b times 1 cubic units, or just b cubic units. But if I multiply that, if I put multiple floors on here, essentially, I'm going to end up with b times h cubic units. So in order to find the area of any prism or cylinder is just the area of the base of the prism or cylinder multiplied by the height of the prism or the cylinder. Alright, let's go back to the first one and give you enough time to write that one down. Now, while it looked like we developed the formula for the volume of a prism in the last exploration, we can actually assume that we developed the volume of a cylinder as well. Remember, a cylinder is essentially a prism just with a circular base. Okay, so once again, the volume of the cylinder is just going to be the area of the base times the height of the cylinder. But the general formula for the area of the base of a cylinder, notice that the base of a cylinder is just a circle, and the area of a circle is just pi r squared. So I can just substitute that into my formula for the volume of the cylinder, so I end up getting that the volume is just pi r squared times the height of the cylinder. Alright, so we gather data about 2 wooden logs that are approximately cylinders. Based on the data in the table, we're going to figure out which wood is denser, the Douglas fir or the American redwood. So we're going to use this information here to determine that. Now the first thing I want to do is find the volume of the Douglas fir log. Okay, well, the volume of any cylinder, since we're assuming that the Douglas fir tree is a cylinder, the volume of any cylinder is pi r squared times h, or the area of the base times the height. Well, they tell us that the radius of this log is 0.5 units, and the height is 6 units. Okay, so in the end, we get that the volume of this log is 4.7 cubic feet, and that's after we multiply this through. I do the exact same thing for the American redwood log. The volume of the redwood log is given by pi times the radius of the log times the height of the log. Okay, and they give us that the radius of the log is 1.5 units and that the height of it is 4 units. So I just substitute those into my volume formula, and once I multiply through, I get that the volume of the American redwood log is 28.3 cubic feet. Okay, so now I want to compare their densities. You have to remember that the density of this wood is going to be the amount of weight per unit of volume. Okay, so the density of the Douglas fir is going to be 155.5 pounds, because that's how much they tell us it weighs, divided by the volume that we calculated in the previous slide. So I get that the density of Douglas fir is approximately 33 pounds per cubic foot. I can do the same thing for the American redwood. They give us this information that the American redwood weighs approximately 791 pounds and occupies a volume of 28.3 cubic feet, which simplifies to 28 pounds per cubic foot. So notice that the density of the Douglas fir is greater than the density of the American wood. So I say the American redwood. So I say that the Douglas fir is denser than the American redwood. Okay, so there's a name for these types of cylinders that you see here. Notice it basically looks like a cylinder that's been pushed over. All right, in a regular cylinder, this line segment between the bases would be perpendicular to each base. In other words, it'd be standing straight up. Okay, but notice that the axis of this cylinder has doesn't make right angles with the bases. So whenever you have something like this, where the axis of the cylinder, right, which is the segment whose endpoints are the centers of the bases, whenever the axis is not perpendicular, we call it an oblique cylinder. So this is called an oblique cylinder. Next, we're going to talk about how do you find the volume of an oblique cylinder, and is it somehow related to the volume of the same cylinder just pushed back straight. Okay, well, Cavalieri's principle gives us the answer to this. If I have two solids that have the same exact height and the same cross-sectional area at every single level, then the two solids have the same volume. So according to that, if I take this cylinder and just push it over, the volume is not going to change, because Cavalieri's principle requires that the two solids that we're comparing have the same cross-sectional area at every single level. So notice if I move this plane up or down, these two cylinders will have the exact same cross-section. So therefore, according to Cavalieri's principle, these two cylinders will have the exact same volume. So if I want to find the volume of this oblique cylinder, it's the same as if I were to find the volume of the cylinder that's actually standing straight up. Okay, so it's the same. I need to I use the formula that we developed for the volume of a cylinder, which is the volume equals base times height. Okay, and notice here that they give us that the base has an area of 64 pi centimeters squared. Okay, so now we just need to figure out how tall this thing is. Well, they don't give us that information on this slide, but they did in the last one. They said that the height of the cylinder shown is twice the radius. So I need to figure out how tall this thing is by calculating what's the radius of a circle that has an area of 64 pi centimeters squared. Well, if you recall, the area of a circle is given by pi times the radius of the circle squared, which in this case is 64 pi. So we have this equation here that allows us to figure out what the radius is of this circle with an area of 64 pi units. Well, if I divide both of these expressions by pi, I get that r squared equals 64. Therefore, r has to be 8 centimeters, since 8 is the number that I squared to get 64. So the radius of this circle here is 8 centimeters. Okay, so what they told us is the height of this cylinder is exactly twice the radius of the base. So the height of this cylinder is 16 centimeters. Okay, so I just substitute that in to my formula for the volume, which is the area of the base times the height. And remember that the area of the base was given to us as 64 pi units, and the height we just calculated 16 units. So I get that the volume of this oblique cylinder is 1024 centimeters cubed. Okay, in this example, we're going to use the formulas that we developed to solve a design problem. So, suppose that we wanted to build a storage box from a piece of plywood that's 4 feet by 8 feet. We have to use 6 pieces, obviously, for the top, the bottom, and the sides of the box. Altogether, we'll have 6 pieces. And you must make cuts that are parallel and perpendicular to the edges of the plywood. So I can't make any weird kinds of cuts. They have to be parallel and perpendicular to the edges of the plywood. What we're going to do is we're going to investigate 3 different designs and figure out which one gives us the maximum possible volume for the box. So we're basically going to be using one piece of plywood, coming up with a bunch of different designs and seeing which one gives us the biggest amount of volume. So if we look at this first design here, this is our piece of plywood that's 4 by 8, okay, and we're making the box so that it has congruent rectangles, 4 congruent rectangles for the top, the bottom, the front, and the back of the box. And these 2 squares here will end up being the ends of our box. Okay, so our goal here is to figure out, first of all, what length are these pieces going to have, and once I do that, I can figure out what the volume of our resulting box, once I glue this thing together, what it's going to look like. Okay, so the first thing I notice is that each one of the heights of each one of these pieces of my box has to be 1 foot, because each one of these have to have the same size, and altogether they have to. I have a 4 foot piece of plywood here, so the value of x in this case has to be 1 foot, right? So since x is 1 foot, that means that this length here is 8 minus 1, or 7 feet. Okay, so I have this length here is 7, this length here is 1. So I have the dimensions of my box, essentially. I have the dimensions of each face of my box and the ends. Okay, so the volume of my box is going to be the base times the height. Alright, so notice that we can call this, let's say that this particular piece is going to be the base of our box. Well, according to our volume formula, the volume of our resulting box is going to be the area of the base times the height. Well, let's work on the area of the base first. Notice that the area of the base is just going to be the area of this rectangle here. Well, the length is 7 feet, and the height is 1 foot. So altogether I have an area of my base which is 7 feet. 7 times 1. That's 7 feet squared. Okay? And now the height of my box is just going to be the length of, let's say, the front part of our box, or even one of the sides of our box, which is 1. So once I put this box together, it will hold approximately 7, or exactly rather, 7 cubic feet of volume. Let's look at this next design. Once again, these are going to be the front, back, and sides of my box. These 4 congruent rectangles here, and these are going to be the ends. Okay, the left and right ends. Once again, I need to figure out the dimensions of my faces of my box that I'm building, so that I can figure out what volume it's going to have. This gray piece right here represents waste. It's going to be wasted. We're going to throw it away. Okay, so once again, I'm creating this box out of these 4 pieces here, and these are going to be my ends, these squares here. So what's going to be the value of x? Well, notice that I have 5 of these pieces, and they're all congruent. So the measurement, or the width of each one is going to be 8 divided by 5 feet, which is approximately, I believe, like 1.6 feet or something like that. Okay. Now if I want to figure out the volume of this box once I put it together, remember the volume of any prism in general, since our box can be modeled by a prism, the volume is the area of the base of the prism times the height of the prism. Well, if we just consider this piece right here, let's say that this is going to be the base of our box. Well, what are the dimensions of this thing? Well, I know that it's 4 feet long and approximately 1.6 feet wide. So the area is going to be 4 by 8 divided by 5 square feet. The height of my box is going to be x once again, which I've already calculated as being approximately 1.6 feet, or 8 divided by 5. So if I multiply the area of the base times the height of the box, I end up getting 4 times 8 divided by 25 cubic feet, which ends up being approximately 10.24 cubic feet. So once again, the volume of the first box, if we go back, it would hold 7 cubic feet, wasting this much material, and this one holds approximately 10.2 cubic feet, wasting if I waste this much material. Now looking at the final design here, I'm not going to waste any material, so we're going to see what the volume of the resulting box will be. Once again, the problem is similar. I have my 4x8 piece of plywood here, okay, and these two end pieces are squares once again, so the dimensions of each square is 2 by 2, so x has to be 2 because both of these have to add up to 4, and these are both congruent squares. Okay, so once again I need to find the volume of the entire thing. Well, let's consider this as it's going to be the base of our box. If that's the case, then the width of the base of the box is going to be 8 minus 2 divided by 2. I say 8 minus 2 because we already figured out that x has to be 2. So 8 minus 2 divided by 2, that's 6 divided by 2. So the width of the base is going to be 3, whereas the height is, or sorry, the width is 3 and the length is 2 units. So the base has an area of 6 square feet. Whereas the height of this box is going to be 2 feet. Because you can think of, if these are the ends of the box is going to stand 2 feet tall. So in the end I end up getting 12 cubic feet. Okay. So if we go back here, which box enables us to hold the most amount of space? It turns out to be this one. This one here, because it holds 12 cubic feet. Okay, the essential question that we answered today is, how do we calculate the volume of a prism or cylinder and use the volume formulas to solve design problems? Well, you can calculate the volume, which we typically denote by V of a prism, and the volume V of a right or oblique cylinder using the exact same formula. So finding the volume formula for both is actually a similar type of problem. You take the volume or the area of the base. If it's a prism, the base is going to be a polygon, whereas if it's a cylinder, the base is going to be a circle. So we use B to represent the area of either a polygon in the case of a prism or a circle in the case of a cylinder. Okay, and then we multiply that by the height of the prism or cylinder. You can solve design problems by using the given information to draw a diagram that meets the given requirements.